Problem 3 says that 675 milliliters of 0.23 molar nitric acid react with excess sodium hydroxide and produce 6.25 grams of sodium nitrate. What is the percent yield of the reaction? So it gives us no equation to go off of, so I'm going to start by writing out the balanced chemical equation. So nitric acid, so H with a +1 charge, and NO3, which has a -1 charge. So nitric acid is HNO3, reacts with sodium hydroxide. Sodium is a +1 charge, and hydroxide has a -1 charge. So sodium hydroxide is just NaOH, and produces sodium nitrate, and then it's also going to produce water, because this is an acid-base reacting together, which is a neutralization reaction. So hydrogen is going to bond with hydroxide, and sodium is going to bond with the nitrate. So sodium nitrate, Na was a +1 with NO3 -1, so NaNO3. And then our second product is going to be water, and I'm going to write it as HOH. Now I need to balance this equation. But if you take a look, there's actually one hydrogen and one hydroxide on each side. There's one sodium on each side, and one nitrate on each side. And so this is actually already balanced. There are no coefficients needed here. There's just one of each reactant and product. So now we can start tackling the stoichiometry. This 675 milliliters of nitric acid, that's our reactant. We have 675 milliliters, and it is 0.230 molar is the concentration. So from that information we can figure out how many moles of HNO3 we have reacting. Now on the other hand, the 6.25 grams, the other amount given of sodium nitrate is actually a product. So 6.25 grams, this must be the actual yield of product. And so I'm going to go ahead and label it as such so I don't get confused later. The amount of product that we're given, this is not the amount that should be produced with this amount of reactant. This is the actual yield. And so we'll need that piece of information because we are asked to calculate out the percent yield as our final answer. And so first we'll need to figure out what is the theoretical yield of sodium nitrate, and then we can take our actual yield divided by the theoretical yield, which we'll calculate to get our percent yield. So let's start by calculating out the theoretical yield of sodium nitrate, and I'll write theoretical yield equals question mark for sodium nitrate. So that's what we need to calculate out, is what is the theoretical yield, so then we can calculate our final answer, which is the percent yield. So we'll start with the 675 milliliters of 0.230 molar nitric acid. So 675 milliliters. Now I know that right away I'm going to have to convert my milliliters to liters. 10 to the third milliliters in 1 liter, so that way I can use my molarity value to get my number of moles. So then 0.230 moles in every 1 liter of my solution here. And this is nitric acid, HNO3. And before I do my mole to mole ratio, I'm going to go ahead and put my substance there. So now I want to go from my moles of HNO3 to moles of my new substance, and I need to know the theoretical yield of sodium nitrate, so then I can calculate out my percent yield. Moles of sodium nitrate. And since my actual yield is given in grams, I do need to take my moles of sodium nitrate out to grams, so that way I have a direct comparison. So 1 mole of sodium nitrate, if you add up the molar mass, sodium plus nitrogen plus 3 oxygens is right about 85 grams per mole. Our mole to mole ratio will come from the balanced chemical equation, but since there are no coefficients, I know that both of these are 1s. It is a 1-to-1 mole ratio here. Now I have all my numbers filled in, so all I need to do is multiply and divide this out. And when I did that, I get 13.196. Now I do need to round my final answer to appropriate sig figs, but this actually is not my final answer. This is the grams of sodium nitrate that should be produced. So this is actually my theoretical yield. Now I have the theoretical yield, so I can calculate out the percent yield. So I'll go ahead and do that. Percent yield is equal to the actual yield divided by the theoretical yield times 100. But we kind of know that part. 6.25 grams is my actual yield divided by the theoretical yield of 13.196 grams. Then of course we will need to multiply by 100 to get that to a percentage. And when I do that, I got 47.4%, which we should round to appropriate sig figs. And in this case, our final answer should indeed have 3 sig figs, so we don't actually need to round it out. 47.4% is our final answer, although you will often see percent yields rounded to just a whole percentage as well.